So let us discuss about project network diagrams. In this video, we will do a detailed activity on node diagram and explain the calculation of float and the critical path. In all activity on node diagrams, this is the notation for every activity or for every node. So there is a place for early start, early finish, late start, late finish, and for duration and for the activity name. So this is how each node is depicted. Now the step 1, here is an activity on node diagram. First activity is remove old sidewalk, duration 20 days, excavate lawn 25 days, build farms 8 days, pour concrete 8 days, and there is a finish to start lag, which is a waiting time. So we need to wait for 16 days before we start remove farms. Then after build farms, we can do replace topsoil, that is 6 days, and lay sod, that is 8 days. Remove farms can happen only after 16 days of pour concrete and after lay sod. Now the first thing we have to do is we do a forward pass to calculate the early start and the early finish. So remove sidewalk, let us start it on day 1. The duration is 20 days, so it gets over on the 20th day. An easy way to calculate this is start date plus duration minus 1. That is 1 plus 20 is 21. 21 minus 1 is 20. Then excavate lawn can start on 21st day, duration 25 days. So 21 plus 25 becomes 46 minus 1, that is 45. Build farms can start on 46th day. 46 plus 8 is 54 minus 1. 53rd day it gets over. So the pour concrete can start on 54. 54 plus 8 is 62 minus 1. 61st day this gets over. And the lag will start. The easiest way is, please consider it as another activity that is easy. So this finish to start, that lag for 16 days can start on the 62nd day. Duration is 16 days. So 62 plus 16 is 78 minus 1. 77th day this gets over. So now we have to do for this parallel path. Build farms gets over on the 53rd day. So replace topsoil can start on the 54th day. 54 plus 6 is 60 minus 1, that is 59. So if this gets over on the 59th day, lay sod can happen on the 60th day. 60 plus 8 is 68 minus 1, that is 67th day this gets over. Now there is a convergence of two paths. Here it is 77, here it is 67, and when there is a convergence of two paths, we will take the highest. So we take 77. So remove farms can happen on the 78th day, and the duration is 4 days. So 78 plus 4 is 82 minus 1. So 81st day, the remove farms will get completed. That means this activity sequence can get over on the 81st day. So what we did is we did the forward pass to calculate the early start and the early finish. The next step is to do a backward pass. Now here we got 81. That 81 we transfer here. So then you start the backward pass. So 81 minus 4 plus 1. That is the easiest way. Or it is 81, 80, 79, 78. So here we get 78. Or it is 81 minus 4 plus 1, which is nothing but 81 minus 3, that is 78. So if this is 78, this is 77. If this is 77, 77 minus 8 plus 1, that is 70. And if this is 70, this is 69. And this is 69, this is 69 minus 6 plus 1. So that is 64. Now we have to do for this path. So here it is 78. So this is 77. And this will become 62. This is 61. This is 54. And now we have a convergence of two paths. Here it is 64. Here it is 54. And when we converge on a backward path, we always take the lowest. So here it is 54. Here it is 64. So this will become 53. So 53 minus 8 plus 1, 46, 45, 21, 20 and 1. So we did the forward pass, calculated the early start and the early finish. Now we did the backward pass and calculated the late start and the late finish. Now float. Float is late start minus early start or late finish minus early finish. So we have to calculate the float for all these things. So yeah, removes all sidewalk is 0, float is here, float is 0, here 0, here 0, here 0, here it is 0, here it is 0, whereas here it is 10. So if I connect all those activities whose float is equal to 0, that becomes the critical path. And that is the longest path in the network also. So here if you see the length of this path, that is 20 plus 25, this will be 81. Whereas the length of this path would be 20 plus 25, 45, 45 plus 8 is 53, 53 plus 6 is 59, 59 plus 8 is 67. Yeah, 67 plus 4 becomes 71. So here we have a if we connect all the activities whose float is equal to 0, that is the critical path and that is the longest path as well. So how much is the float for the entire path is 10 days. Put together, all these activities put together, it can be delayed by 10 days. That is the total float for this path. 10 days is the total float for this path. And what is the free float? That is the amount of time an activity can be delayed without affecting the early start of the successor activity. Yeah, so amount of time an activity can be delayed without affecting the successor activity. So in this case, 67, 78. So even if I delay this by 10 days, the successor activity will not be delayed. So in this case, our free float is also 10 and the total float is also 10. So we did the forward pass, calculated the early start and the early finish. Then we transferred the early finish here and we started the backward pass. And we worked out the float for all tasks. and we connected the path with zero float. That is the critical path, and that is going to be the longest path as well. Now once we have a diagram like this, a scheduling packages, what it does is, if you can give the start date, it will look at the company calendar defined and block off all the holidays and stuff like that. So it will refer to the organization's calendar, and if I give a start date, the tool will automatically work out the end dates and give me those dates. That is exactly scheduling tools, what the scheduling tools does. So we have this activity sequence diagrams, maybe multiple for each discipline, and we merge it together into a cohesive integrated project schedule, and the tool works out the critical path, and the critical paths, through trial and error, we have to optimize them. So through crashing and fast tracking and stuff like that, for which I'll release another video talking about crashing and fast tracking. As a prelude to that, what is crashing? Crashing is all about putting more resources into an activity so that I can reduce the duration of that activity. That is crashing. Whereas fast tracking is trying to do things in parallel which were originally scheduled sequentially. So by trying out crashing and fast tracking, we can adjust the duration of the critical path and before finalizing the schedules. Thank you. Yeah, if you have not subscribed to this channel yet, please do subscribe so that you will not miss out any of the latest updates. Thank you very much.